So, which quadrant is this one? And then if I wanted to label 2, where would it be? Upper left or bottom right?
Upper left.
All right. So you know from your, basically since probably elementary school, that the XY coordinate system is kind of ordered in this way. If you've had pre-calculus, then you know that this represents 0 degrees, right? The positive X direction. And that an angle would be measured counterclockwise relative to the 0 degree mark, making this pi over 2 or 90 degrees. This is pi or 180 degrees. This is 3 pi over 2, good job, or 270 degrees. And then we come back here, right? 2 pi. And I would argue that my pre-calc people know that any point that I place here, which has an X and Y coordinate, X is R cos theta, and Y is R sine theta. And that's what you learned, I'm pretty sure. If you didn't use R, you used something similar. That's going to screw you up, all right? And it's going to screw you up frequently and often, because you are now hardwired and trained to do it this way all the time. That's going to be a problem. First, the world doesn't work like this. Well, I guess I can leave that there. I'll leave the 90 degrees there. But if I gave you a map, that would be north, right? Which one would be east? Well, I don't know what direction you're pointing. Is it the 0 degrees one or the 180 degrees one?
0.
Okay, yeah, all right. So there we go. And so west and south. Is that good so far? By the way, can you point towards the east in my room? Like, which wall is the east wall? I do so love. If I was to put a map on the board, and we being in the northern hemisphere generally put north upwards on our maps, north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. That's how runways are numbered. They're numbered with the direction they face. So you understand right away, the real world puts 0 at positive y and goes clockwise. So if I tell you to walk somewhere, which one are you going to use? You've been trained one way, but that doesn't really reflect how the world works. You know, if I tell you that a plane is flying horizontally but then starts a dive, well, what direction is horizontal and what direction would the dive be? Would that be a positive angle, a negative angle? How would you understand? Situations require that you be flexible. There's nothing wrong with using a coordinate system. There's nothing wrong with setting a stage for a coordinate system, meaning identifying what you will call the positive direction. What you have to understand is that that's just the beginning. You're supposed to have enough awareness that you can use your skill set and be flexible enough to apply it in new circumstance. But I've got 26 years of data that suggests you won't. So every year I try to start a little differently to see if I can break this cycle. The problem is that I have some of you who have already been through pre-calc. You're the ones whose cycle I need to break. And I have some of you who are going to go through pre-calculus, in which case what we do is more flexible than what you'll be allowed to do on the unit circle work you're going to do in pre-calculus later this year. So just be aware, there's a reason why your pre-calculus class does it the way they do it. And part of it is because that's their curriculum. And part of it is test scores, quite frankly. But in this class, a force can be in any direction, and it's a vector, and you might have to break it up into x and y, and you will choose what direction is x and what direction is y. You'll have to be flexible. So I'm going to start my conversation today the way I started it yesterday, which is I'm going to give you a triangle, and we're going to walk through a series of steps. And I'm going to stick with, I think, what I did yesterday, just so I can be consistent. I believe the one we were doing yesterday was 25 meters and 12 meters. Is that right?
Yeah.
All right. I will assume that I'm starting fresh. I said you can keep a piece of paper out that you'll use as your... All right, so step one. You have to identify the angle of interest and the right angle. Yesterday, I identified that for you. I told you I wanted to use this angle. That means I'm telling you the angle that I am interested in. And I told you this is the right angle. So step one is identify the angle of interest. Step two, label the sides correctly for opposite, adjacent, and hypotenuse. So hypotenuse there, it's across from the right angle. Opposite side is opposite or across from the angle of interest. And adjacent side is the one that's located next to the angle of interest. Next, write out SOHCAHTOA. And I don't mean the 9 letters. I mean write out sine, cosine, and tangent. Leave some spaces and include opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Next, step 4, fill in what you know from your triangle. So I know the opposite side is 25, so I'm going to go through and replace all the opposites with 25. I know the adjacent side is 12, so I'm going to go through and replace all the adjacents with 12. Now, it's at this moment that you will have to reach an impasse, a point where you'll have to ask yourself a choice. And this is where there's a branch in your set of steps. And so the steps are going to be renumbered after this, starting back with number 1. You have to decide which branch to choose. Look, it's going to come down to this. You either have 2 sides or you have a side and an angle. It's one or the other. You could have more information, but likely minimum you'll have that. We have 2 sides. So because we have 2 sides, somewhere in your notes, start up step number 1 for having 2 sides. Step number 1 is pretty simple. If you have 2 sides, that means you have one of the ratios. Compute the one ratio you know. So I know one of my ratios. It's 25 divided by 12. So my ratio, 2.0833. Go at least 4 decimal places here, maybe more. The more that you have here, the better your answer will be. Intermediate steps. You should use as many decimal places as you can. Step 2, check to make sure your calculator is in the appropriate degrees or radians. You're going to write this step down twice. So if you screw this up, you are willfully ignorant. Okay? And I recorded that because it's true. Almost all the time in my class, I will want my answer in degrees, or I will give my angle in degrees. This one, I want the angle in degrees. Now, there are times when we're going to use radians, but it is until second semester. So you can rest assured that this whole semester, degrees. Now, here's the part that is different depending on your calculator. You need to figure out the angle that corresponds with this ratio. Now, if you're given 2 sides, this means you're going to be using the inverse or the arc of your sine or cosine or tangent. So for my calculator, it shows an inverse tangent, which is tangent to the -1, and an inverse sine and an inverse cosine. Calculators are sometimes different. Sometimes they say arctan or arcsine or arccosine. But most modern calculators are going to say inverse. If you're given 2 sines, you're going to use the inverse because you have the ratio and you're looking for the angle. So I happen to have the ratio for tangent. So I'm going to hit the second tan button, type in my 2.08333, and hit enter. And it should tell me what angle goes with that ratio. And it did, 64.35899. Now I don't have a whole lot of room to write that. I'm going to write 64.35899. 0.36. And write the angle in for all three ratios. So, your step was to find the angle that goes with the given ratio, and then write that angle in to all of your functions, all of your trig functions. Your next step, compute the remaining two ratios. So, sine of 64.36 is 0.9015. Cosine of 64.36 is 0.4327. I'm computing all of the remaining trig functions and finding all of the ratios. So I now have the remaining two ratios. Now, once you have found the other two ratios, there should be a pathway for you to figure out the missing side. Meaning there should be a ratio where you have one side, a missing side, and whatever the decimal is that goes with that ratio. I actually have two of them. Now, although I know you can get h by doing the Pythagorean theorem, I said yesterday, and I'll reiterate it today, I'm showing you how to do everything using trig. So although you have an alternative, this is using nothing but trig to find the answer. That suggests that the Pythagorean theorem will be an excellent way for you to check your work. But I'm going to pick one of these ratios to determine h, and I'm choosing the sine, so 25 over h equals 0.9015. And yeah, I know there's a subset of you guys who cannot solve this for h. So this is the one time I'm willing to show the work. Multiply both sides by h. And we talked about this earlier in the year. Divide both sides by 0.9015. And I find that h equals, let's see, 27.7. Now, we used the sine ratio for that, and that gave us our missing side. However, keep in mind, you have a way to check your work without using Pythagoras. We know that this number had to be bigger than 25, because it was 25 divided by a number gave us 0.9. But you can check right here by taking 12 divided by 27.7 and seeing if it equals the remaining ratio of 0.4327. If it doesn't, you've made an arithmetic mistake. And it's an easy way to catch arithmetic mistakes. It won't catch logic mistakes, like if you use the wrong angle, but it will catch arithmetic mistakes. So when you say I made a silly math mistake, this is the one that will catch it. You're choosing not to catch it if you don't check your work. All right, pretty easy. I gave another one, I recall, if I'm right on that, and it was, I think in this one I gave a side and an angle. So what was the angle I gave? 37 degrees, and I don't remember which side it was. Which side was it? So this was 10? All right. So we're going to do this one because this is the other branch, right? But I'm going to go through the same series of steps. I'm going to start by identifying the right angle and the angle of interest. The right angle's here, and my angle of interest was given to me. It's 37 degrees. That makes this the opposite side, this the hypotenuse, and this the adjacent side. So step 2, label your sides. Step 3, write out sine, cosine, and tangent. In writing it out, fill in what you know. I know opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And I know 37 degrees. Replace the side lengths with the side that you know. I did. I did it as I was writing out my trig chart. Now, again, this is a branch. So you've reached the end of your first set of steps, but this branch is different. This is where you have a side and an angle. If you had a side and an angle, start a new set of steps. Step 1, check to make sure your calculator is in degrees or radians, depending on what you were given. You were given an angle. That dictates whether your calculator should be in degrees or radians. So step 1 is to check and make sure. Step 2, calculate all 3 ratios from the given angle. So my angle is 37 degrees. So sine of 37 is 0.6018. Cosine of 37, 0.7986. And tangent of 37 is 0.7536. So again, step 2, compute all 3 ratios. I computed all 3 ratios. Step 3, find a ratio that will allow you to solve for the missing side. I have 2 ratios that will let me solve for the missing side. This is the first ratio, and this is the second ratio. So take a moment, solve for the missing sides. I'm going to call on one of you here in a minute. You should be pretty close to being done, I think. All right, I think that should be enough time. Who can give me the hypotenuse? Yes, sir. 16 point what?
62.
Who can give me the adjacent side? Yes, ma'am. 13.26? 7? Now, I don't know if these are right or wrong. I just grabbed them from you guys. But I know that I can find a way to check because there should be a ratio you didn't use. And because you didn't use it, you can use that ratio to test if your side lengths are correct. So 13.27 divided by 16.62 had better be 0.7986 or close to it. If it's not, then somebody's arithmetic is wrong. Now I could use Pythagoras to check too if I wanted. So you have 2 methods to check. All right, let me pause right here. We're going to be talking about vectors today. And I want you to understand that vectors come in a variety of terminology, but for the most part, a vector is anything that has both a size and a direction. So I could tell you that the wind is blowing at 100 miles an hour due east. That's a vector. The size part's 100 miles an hour, due east is the direction. I could tell you that you're going to walk to the mall, which is 4 miles to the southeast. I'm giving you a bit of a direction, and I'm giving you how far away it is. Now, I need you to learn how to add, subtract, multiply, and divide vectors. So we're going to start with some simple vector work to show you how to do that. But it's a basic three-step process. You have to convert all your vectors to rectangular. You have to add together like components. And then you have to return your answer to polar. That's the process. And you may not know what any of those steps mean, but that's the process. You'll need to convert all your vectors to rectangular. You'll need to add together like components. And you'll need to convert your resultant back to polar. Let me show you what this means. I'm going to start with the coordinate system. And in this coordinate system, I'm going to label north, east, south, and west. Somebody, actually, I don't want to leave it to you. I want to choose something. I want you to walk to this point right here. That point in polar is 10 meters away from the origin at an angle of 25 degrees west of north. All right. A lot of students struggle with what I'm about to talk about. And likely you will be one of those students. Polar notation gives you a magnitude of your vector and a direction. However, it's important to understand that telling you that your magnitude is 10 and your direction is 25 degrees doesn't tell you anything. But saying 10 meters and 25 degrees west of north is very clear. We assume that our origin is located somewhere in space. But to provide you with an angle requires first that we tell you where 0 degrees is. We need to give you a point of reference. I'm choosing to use map point of references because I think that they are something that we all share. We know a little bit about north, south, east, and west. But also I'm choosing that purposely because it's not X and Y. Because later in the year, you will have to choose coordinate systems on your own that work best with the situation you've been provided. So I want you to be used to switching from one coordinate system to another. So north, south, east, and west is an easy one for us to use. Many students struggle with the phrase west of north. I want to tell you that it's written backwards. If you want to understand how 25 degrees west of north works, the idea is that you start facing north and you turn towards the west 25 degrees. That's how the statement works, because you are now facing 25 degrees west of north. So if you want to understand where that came from, look closely at the picture. In the picture, I start facing north. And then I turn towards the west 25 degrees, so that I am now 25 degrees west of north. I will need you to be able to do that. And I will need you to do the reverse. Be given a result and figure out how to express its direction. Now, let's say you can't walk directly to this point. Say there's a building in the way. And like on any city grid, there's probably a set of streets that face north and south, or east and west. So to get to this point, you might have to go around a building. Does that make sense? We call the vectors that would go north, east, south, and west, component vectors. Components are two vectors at right angles to each other that describe another vector. Components. I'll use that phrase a lot this year. Components are two vectors that are at right angles to each other that describe another vector. Components are two vectors at right angles to each other that describe another vector. So, I've described a point in space. I'm using a vector to point to it. What I would like to figure out are what are the two component vectors that can be used to describe this vector. Now, the truth is, there's an infinite number of possible component vectors. There's lots of different right angles that could be drawn that could get me to that point. I could go out this way, and then make a right angle turn and go that way. That is a pair of component vectors. Generally, we look for components that are useful. For example, I've given you a coordinate system with north, south, east, and west identified. I want the component vectors that are aligned with the cardinal direction. Okay? So, once we begin this process, once you have a coordinate system, and you identify that you have to find the components of a vector, the next thing I would encourage you to do is go ahead and fall back on what you've been trained. Label positive x and positive y. It will make what we do next easier. Even though there's north, south, east, and west, fall back on positive x and positive y. So I'm going to label positive x this way and positive y that way. That makes this negative x and makes this negative y. Now the next phrase I'm going to use is often one confused by students. But you need to find your components. You need to draw a triangle. This is the hardest part, and students make mistakes here all the time. So I'll give you a hint. If you want the most success, follow this phrase. Wrap your triangle around the given angle. Wrap your triangle around the given angle. Because I will point out that there are two different sets of triangles that can get me to here. There's the one that goes this way and this way. And there's the one that goes this way and this way. Either one of those two sets of components will get me there. And arguably, most people in the room realize that they're the same length sides, just in a different order. In one of them, I go north first and then west. The other one, I go west first and then north. Really doesn't matter which one you choose, except I was given 25 degrees. Now, if you know that there's an angle that goes with that, you're welcome to do it the way you'd like, but I would strongly encourage you to use the angle that you're given. So much so that I will require it. Look, the reason why you should use the angle that you're given is quite simply, in the future, we won't be given an angle, we'll be given a symbol to represent that angle. And if your answer has to be in terms of that symbol, you can't use a different angle. Does everybody understand what I'm saying? So if not, I will mandate it. Use the angle you're given. That means for us, we're going to use this set of components because I'm wrapping a right triangle around the angle I was given. Now you have a set of instructions that should be able to figure out the lengths of those components. Right? You have identified a triangle. Look, the hardest part here is to get to the triangle part. You now go back to your set of steps and you tell me how much in the north direction and how much in the west direction I have to walk. I shouldn't have to help with that. And I don't intend to. You have made a mistake. And you need to check your work. But I promise those are they, because those are my answers. So check your work. It's sine, cosine, and tangent. And in this case, you would have used sine and cosine. And for all of you from pre-calculus, you should notice very clearly, the y component went with cosine, and the x component went with sine. That was a purposeful choice I made because of where our angle is based. So for you guys who are coming from pre-calculus, and you're in calculus now, understand that you take the angle as given, not the one that you would like to use based on your work in pre-calc. Because pre-calc would have had you use not 25 degrees, but would have had you use, 110 degrees, 115 degrees. We're not doing it that. We're not doing that at all. Now, this is an intermediate step. And you don't understand why yet, because the problem isn't done. We have taken our vector and found two component vectors for it. One of them in a positive y direction, and one of them in the negative x direction. For right now, we have taken our polar vector. That's the way this was written, in polar notation. And we have converted it to rectangular. The way I'd like you to write that is negative 4.22 x hat plus 9.06 y hat. The x with the little hat on it says 4.22 in the x direction. And the y with the little hat means in the y direction. This is an intermediate step, but is a method for writing rectangular components in the same way that you could have written it as an ordered pair. This is another way of writing the component vectors. I don't use ordered pairs though. I use a relationship that includes unit vectors. So x hat and y hat's what I want you to use. You could have said 4.22 west and 9.06 north. That would be okay. But for what we're going to do next, please label an x and y. Because what I'm going to ask you to do is to add vectors together. And vectors can only be added together if they're in the same one dimension. So what if I told you you're going to walk another 5 meters, 30 degrees south of west? 5 meters, 30 degrees south of west. And what if I want you to figure out where are you now compared to where you started? This is what I need you to do. Now that means there's another vector here, 5 meters, 30 degrees south of west. The only way we can do this is if we convert this first to rectangular. And then from there, add our components together. Now, I know this is a lot to throw at you. So I would encourage you to avoid some distractions. Perhaps make yourself another quick little coordinate system and only work on this vector here. This new vector is 5 meters, and it's 30 degrees south of west. Start from the west, turn towards the south, 30 degrees. We're going to need its components, which means you need to wrap a triangle around the given angle. You need to identify the right angle here. Using your identified angle, you should label the sides. You should write out your ratio. You should note that this one gave you an angle and a side length, so you can compute the 3 ratios. you could use your two ratios to figure out the opposite side and the adjacent side. I know I'm going fast. I'll give you a moment to catch up because some of you are struggling a little bit. Now that I have found my two sides, I realize the 4.33 is in the negative x direction, and the 2.5 is in the negative y direction. So in this chart that I've made, I'll have minus 4.33 x hat minus 2.5 y hat. Now, here's the thing. If you need to add or subtract vectors, they have to be converted to rectangular first. You can then add together like components. So the ones with x hat, I add them together. And the ones with y hat, I add them together, but I add them together separate. So when I add these together, I get negative 8.55 x hat minus 6.56 y hat. This is the actual result. It tells me that if I want to know where that person is now, I go out negative 8 in the x direction and, oh, wait, that should be positive 6. Positive 6 in the y direction. Now, we're not done because you probably note that the next thing I'm going to need you to do is figure out what angle that is and how many meters that is so we can point to it. So your job is to convert back. We are practicing this tomorrow. I'm putting two homeworks out.